So let's go ahead and do these last few problems that I have. So sorry about that. It is kind of late tonight too, so trying to get this done. Carbon 14, present within living organisms and substances derived from living organisms, is often used to establish the age of fossils and artifacts. Determine the number of protons and neutrons in carbon 14 isotope. Write its symbol in the form of A over Z X. And so this is number 95. So basically, we know we have carbon. And if you look, you can go to the periodic table and look, and carbon right there is 6. So we know that we are going to have the atomic number of 6. Now, it says carbon 14 here. So this is telling us what the actual mass is. So for writing this, then basically it's going to be 14 over 6 and our carbon like this. So essentially our Z is here, right? And our A is here. Now you can figure out how many protons and neutrons by the following. The atomic number equals the number of protons, right? So that's Z, which is 6. How many neutrons we have? Well, you have the atomic mass minus the atomic number. So we have 14 minus 6, which equals 8, right? And that is the number of neutrons. So this one wasn't too bad, right? Seemed like it was going to be scarier than what it was. So let's look at this. This one's a little bit more intense. It's number 97, and it basically says rubidium has 2 naturally occurring isotopes, Rb85 with a mass of 84.911 atomic mass, 8 atomic mass units, and a natural abundance of 72.17%. And rubidium-87 with a mass of 86.9092 AMU, and a natural abundance of 27.83%. Calculate the atomic mass of rubidium. And so basically, when you calculate the atomic mass of an element, it involves taking a weighted average in which you multiply the percent natural abundance by the atomic mass for each isotope, and then adding these products together. So basically what I mean by that is the atomic mass is going to be equal to the summation of the isotopic abundance times the isotopic mass. So what does that look like? It sounds a lot harder than what it is. Let's start with Rb85, right? Well, how much of there is there? Well, it's 72.17, right? So how do you determine that in decimal? 72.17 divided by 100, right? And that will give you 0.7217, right? And so basically you take that 0.7217 and you multiply it by the atomic mass. 84.9118 atomic mass units. And then you add to the next one, which is rubidium-87. And we have how much of that? 27. So we do the same thing as we did before, 27.83 divided by 100. And then basically what you get there is 0.2783 times 86.9092. And that's going to give us the average weight of 85.47 atomic mass units. And we do 4 sig figs there because that's what we have in our calculation. Let's go to number 80, let me see, bromine, which one is this? The last one was number 97. This one is number 99. Sorry, I didn't put that on there. So we are at number 99. And let's look at this. Bromine has two naturally occurring isotopes, Br79 and Br81, in an atomic mass of 79.904 atomic mass units. Is the natural abundance of Br79 is 50.69%. What is the natural abundance of Br81? Well, if we have this, right? If this is our natural abundance is 50.69%, well, the only thing that we have to do is take is take 100% minus 50.69, and you get 49.31%. I think it's time for me to go to bed. It's almost midnight here. I only got 2 hours of sleep last night. And so, yeah, if it says the natural abundance of this is 50.69%, then what's the other one? Because there's only two of them here, right? And so you start with 100% and you subtract the percent here, and that's what you get for the first part. Now, the second part says, if the mass of Br81 is 80.9163 AMU, what is the mass of Br79? And so on this, what we're going to do is we're going to look, and basically what's going to happen here is we know that we add the natural abundance, we multiply the percentage times the mass for each one. And so if we look, it says we have Br81 equals this. So basically we have here, we have for here, and we can look at this last thing, we have Br81 weighs this much, and we don't know what this weighs, right? But we know Br81 has 49.31% of the total mass is there, right? And so we can put 0.4931 times how much it weighs, which is 80.9163 atomic mass units, plus, well, we know that this Br79 that we're looking for, right, is 50.69%. So then we go 0.5069, but we don't know. We're looking for the mass of it, right? Basically, that is the big conundrum here. It's like, what is this mass? So essentially, we don't know. So we are going to put a big X in there. But we know that the total, right, the bromine has two naturally occurring isotopes, and the atomic mass is this. So they'll add up together to create 79.904 atomic mass units, right? And so basically, when we multiply this out, that we can get here, we can multiply these two guys together and then add, go here, and we will get it set up where we have the mass equals 79.904 minus 39.90 divided by 0.5069. 5069. And then essentially we will get 40 divided by 0.0069, which equals 78.92 atomic mass units. So we basically, what I did is I multiplied these together and then I subtracted it from this side and then I divided it by that. And now we're at number 108, the challenging question. So determine the number of protons and neutrons in each isotope of chromium and use the listed natural abundances and masses to calculate its atomic mass. And so basically what we're going to do here is we're going to do how many protons and neutrons do we have for each one of these. So if you look here, we can go, let me go here, hold on. And let's go to chromium on our periodic table so we can see what the atomic number is. So the atomic number for chromium is 24. So let's go back here and let's start. Atomic number is 24. So for every single one of these, it's going to be 24 for the number of protons, right? Now, we determine the number of neutrons by taking the atomic mass here and minusing 24. So here we get 26. Here we get 28. Here we get 29. And here we get 30. That wasn't too bad. This kind of puts into play what we've done earlier in this section, right? And now what we're going to do is determine the number of protons and neutrons. We've done that. Use the listed natural abundance and masses to calculate its atomic mass. So this is pretty easy, right? We just say the mass for chromium is going to be 0.04345 times what? The atomic mass. So all these, you're just doing that divided by 100 so you can find out what the percentage is, and then we're going to add them together. So the next one is 0.8379 times 51.9405. The next one is 0.0986 times 85.9093. Let me see. 50, oops. I'm just randomly don't know what I am doing. So we have this 9, 0.9, sorry guys, 50 times 52.9407. And then the last one is 0.02365 times 53.9389. Remember to always write your units, which I forgot, atomic mass units here. And then you multiply and you add it all out, and basically what you get is 2.170 plus 43.52 plus 5.0. Ugh, I have another one. Hold on, guys. You're going to hate me. Chromium. This is going to be 2.170 plus 43.52 plus 5.03 plus 1.276, which equals 52.00 atomic mass units. So that just put everything we learned for this whole section together in one awesomely challenging question. And now I am finished with this unit, and hopefully we will get to do another one soon. Have a great night, guys. Bye.